Good day everyone. For today's report, we have colloidal nature of proteins, denaturation, reagents that cause denaturation. But first, let me introduce to you the reporters, Danica Bonane, Junaya Bernalo, Francel Del Socorro, Sherilyn Pelayo, and Princess Sinahon. Colloidal nature. When proteins are in water, they form a colloidal depression. Due to this property, proteins will not pass through a membrane. This is very important because proteins present in bloodstream cannot pass through the capillaries and should remain in bloodstream. Therefore, there should be no protein in the urine. So if there is a protein in urine, it indicates that there is a damage in the kidney membranes, possibly nephritis. Denaturation is a process in which a protein loses its native shape due to the disruption of weak chemical bonds and interaction, thereby becoming biologically inactive. In case of proteins, a loss of three-dimensional structure is sufficient to cause loss of function. Loss of secondary, tertiary, quaternary structure of proteins, change in physical, chemical, and biological properties of protein molecules. Denaturation involves transformation of a well-defined folded structure of proteins formed under physiological conditions to an unfolded state under non-physiological conditions is called protein denaturation. Proteins can also be denatured by heat. Heat increases molecular motion which can disrupt the attractive forces. None of this agent breaks the peptide bonds, so the primary structure of proteins remains intact when it is denatured. When protein is denatured, it loses its function. Example, a denatured enzyme stops its function. A denatured antibody no longer binds to its antigen. A denatured milk protein loses its biological activity. For some examples, changing pH denatures protein can change the charges on many of the side chains. This disrupts electrostatic attractions and hydrogen bonds. Certain reagents such as urea and guanidine hydrochloride denature proteins by forming hydrogen bonds to the protein groups that are stronger than the hydrogen bonds formed between the groups. Detergents such as sodium dodeoxyl sulfate denature proteins by associating with the non-polar groups of protein, thus interfering with the normal hydrophobic interactions. Organic solvent such as acetone alcohols denature proteins by disrupting hydrophobic interactions. The denatured state does not necessarily mean that complete unfolding or denaturation of protein and randomization of conformation. Under some of these conditions, these proteins exhibit both properties such as denaturation and renaturation. Mechanism of protein denaturation. Unfolding of native proteins occurs at both the temperatures. At higher temperature, denaturation occurs, means it is called heat denaturation or thermal denaturation. And if denaturation occurs at lower temperature, then it is called cold denaturation. In both the cases, there is a breakage of hydrogen bonds, disulfide bonds, hydrophobic interactions, van der Waals forces, but there is no breakage of peptide bonds during denaturation. Causes of protein denaturation. Denaturation occurs when proteins are exposed to an extreme environment conditions such as high level of salt, higher level of acidity, higher temperature, etc. Because of these extreme conditions, the function of the proteins alters due to deformities along these bonds and can be temporarily or permanently denatured. For the reagents that cause denaturation, we have the next reporter, Ms. Sherilyn Pelayo.